Section 12.9b is about extraneous solutions. We're going to solve these rational equations the same way we did in 12.9a, but now we're going to take our answers and plug them back in because there's a possibility that they could be extraneous. So we'll talk about that when we get to that part at the end. Start here by looking for the LCD of all the fractions here. Looks like x minus 1. So we take that x minus 1 and we multiply it by every term. Remember, our purpose is to get rid of all fractions. So here we'll cancel, leaving a 3x. Cancel x minus 1, leaving a 6x minus 9. And here we're multiplying, so I'm going to distribute the 6x minus 6. Like terms on the same side, so 9x minus 9 equals 6x minus 6. I like to move the smaller coefficient, so I'll subtract the 6x, leaving me 3x minus 9 equals negative 6, and then we'll solve. 3x equals 3, and then divide by 3. So x equals 1. So we get a solution of x equals 1. But now I want you to go back to the original equation, and I'll make a duplicate copy over here to show you that. We're going to take this x plus 1, or excuse me, the x equals 1, and we're going to plug it in. You don't have to plug it into the whole thing. What we're really looking at here is the fact that these are fractions. And remember, when you have fractions, you cannot have a 0 in the denominator of a fraction. So I'm going to take the number 1, and I'm going to plug it into the denominator. If I put a 1 in for this x, 1 minus 1 will give me a 0. So what happens is it turns out that this x equals 1 actually does not work, because you can plug it into one of these denominators and you're going to get a 0. You're going to get a denominator that can't happen. So we say that this answer of a 1 is extraneous, which means I have no more answers. So my official answer to this whole problem here is no solution, because 1 is extraneous. This example is one of the hardest ones you're going to see, so let's get right into it. One thing I notice about the denominators is I'd like to factor this n squared minus 1 to be n plus 1 and n minus 1. If you can factor, you should, and that creates my factors that I can use to find my LCD in a little bit. The other thing I notice is 1 minus n. I'd like that to be n minus 1 so that it fits the one over here. Well, how can we do that? How can we change this to be n minus 1? And the answer is we take out that negative 1 idea. We've done that in the past. So now I'm going to rewrite my problem by taking the negative and moving it up. So negative 2n over n minus 1 plus n plus 3 over n plus 1 n minus 1. And that still equals 1. So as far as I'm concerned, that's a lot easier for me to find my LCD now. So take every factor, the maximum number of times that it appears. I see 1n minus 1, 1n minus 1, so I'm going to pick 1n minus 1, and then I see an n plus 1. So I'll pick that as well. Because this is a rational equation, I'm going to multiply every term by my common denominator. So now we'll cancel. N minus 1s will cancel, and I'll deal with this distributing in a little bit. I don't want to confuse you any more than we probably already have. Cancel n plus 1s, cancel n minus 1s, and then we'll just write this as n plus 1, whoops, n minus 1, n plus 1. So now we'll distribute here and here, negative 2n squared minus 2n plus n plus 3. This creates a difference of squares. Right here, n squared minus 1 factored. So now I'm going to put it back together to make it n squared minus 1. I see like terms that are on the same side to be a negative 1n plus 3 equals n squared minus 1. I like to keep my squared terms positive, so I'm going to add 2n squared over here. But that means I'm also going to bring the n over, and that means I'm also going to bring the 3 over. So it's all going to be equal to 0 here. And let's see what we get. We get 3n squared. Then I'm going to put the n in the middle because we like to do things in descending order. And then we get minus 4. So there's my trinomial that I'm going to use. I'm going to factor that using a diamond. I'm actually going to go over here and do that. 2 factors of negative 12, because 3 times 4, remember, you multiply 3 times negative 4, that add to be 1. Those 2 factors are going to be positive 4 and negative 3. So now we use the master product. Remember, we take the leading coefficient of 3, and we take 3n plus 4, and then we also use 3n and put minus 3. This part does not need to deflate, but this part does need to deflate. Pull that 3 out and left with an n minus 1. Okay, so that's using the master product. So that becomes 3n plus 4 and n minus 1 is how that trinomial factors. Now we'll set each one equal to 0. I'll actually write that step out since we're doing so much work here anyway. We might as well do it all. Subtract 4. So 3n equals negative 4, and then we'll divide by 3. So we get an n equals negative 4/3, and then over here we'll just add 1. So we get an n equals 1. So there's actually 2 solutions here, negative 4/3 and 1. Now we do have to take those and go back and see if any one of those solutions will cause one of my denominators to be equal to 0. So here I'm going to use the technology and bring it down here close to my solution so I can see. Do any one of these numbers create a 0 in the denominator? And the answer is yes. This n plus 1, or excuse me, this n equals 1 will cause a 0 here and here. So we cross that out. The other one, negative 4/3, is fine. So that's my final solution.